Alright, let's continue. Okay. First thing first, I want to add an explanation about this one. String guessing. Okay. Token put this in the chat. Does anyone curious? Further down. So reference environment. The easiest one that I can think of is using for loop, using it looping to, what is it called, to print out the symbol in the environment, something like that. Well, let's try that out, I guess. Release. Let's try this one. Okay. And then returning same. Let's try out this, and then put in it. Maybe calling this built-in symbols. To view. Oh, okay. Wait a minute. I should get an error. Right, okay. I'm adding this to make it uniform. And prefix. And now symbols. Oh. Let me think. Something like If I am not gonna I am not gonna make this function take an argument. Symbol does not exist. But if I do this, right? Interesting. Fifteen. Yeah. So I'm like not. I think this like this. I mean, just using the what is it called? The usual env put directly. Let's take a look at the next chapter. Okay. Oh. Okay. We are defining a function. And print in lambda. How many content again? Okay, string. And compare, I guess. I think the if function. Oh, interesting. Then what about string? Quite complex. The name values in environment. What should I do? I mean, I'm also curious about this chapter. You know what? Let's do this. Maybe next time. I want to continue this first. Okay. Functions are the essence of our programming. In the early days of computer science, they represent a naive dream. Oh. The function represents a naive dream. Interesting. The idea was that they could reduce computation into these smaller and smaller bits of reusable code. Okay, given enough time and a proper structure for libraries, eventually we would have written code required for all compositional needs. No longer would people have to write their own function, and programming would consist of an easy job of stitching together components. Okay. This dream hasn't come true yet, but it persists, no matter how flawed. Each new programming technique or paradigm that comes along shakes up this idea a little. They promise better reuse of code, better abstraction, and an easier life for all. In reality, what is paradigm delivery is simply different abstraction. Each new programming technique or paradigm that comes along shakes up this idea a little. They promise better reuse of code, better abstraction, and an easier life for all. In reality, what is paradigm deliver is simply different abstraction. There has always been a trade-off, yes. This is the one. For each higher level of thinking about programming, some piece is thrown away. Okay. And this means no matter how well you decide what to keep and what to leave, occasionally someone will need that piece that have been lost. But through all of this, one way or the other, functions have always persisted and have continually proven to be effective. We have used functions in C, we know what they look like, but we don't know exactly what they are. Here are a few ways to think about them. That make me remember. Back then, maybe around the middle of this live stream series, someone asked me what is a function. So maybe they can check or take a look at this. Okay, let me copy this in the chat, I guess. Okay, keep it up. Alright. Hello, Tony Tornado. Welcome. Okay. We have used function in C. Okay. One way to think about function is as description of some computation you want to be performed later. Some computation you want to be performed later, okay. Description of some computation you want to perform later. When you define the function, it is like saying, when I use this name, I want that sort of thing to happen. This is very practical idea of a function. It is very intuitive and metaphorical to language. This is the way you would comment a human or animal. Another thing, And about this is that it captures the delayed nature of function. Functions are defined once, but can be called on repeatedly after. Okay. Another way to think about function is as a black box. Oh, okay. It takes some input and produces some output. Okay. This idea is subtly different from the former. It's more algebraic and doesn't talk about computation or comments. This idea is a mathematical concept and is not tied to some particular machine or language. In some situations, this idea is exceptionally useful. It allows us to think about functions without worrying about their internals or how they are computed exactly. We can then combine and compose functions together without worry of some subtle going wrong. This is the core idea behind an abstraction. Okay? It's what allows layers of complexity to work together with each other rather than conflict. Work together with each other rather than conflict. Okay. This idea's strength can also be its downfall, because it does not mention anything about computation. It does not deal with a number of real-world concerns. How long will this function take to run? Is this function efficient? Will it modify the state of my program? If so, how? A third method is to think of function as partial computation. Like the mathematical model, they can take some input. Okay. These values are required before the function can complete the computation. This is why it's called partial. These values required before the function can complete the computation. But like the compositional model, the body of the function consists of a computation specified in some language of command. These inputs are called unbound variables. Oh. The body of the function consists of a computation specified in some language of command. Unbound variable. And to finish the computation, one simply supplies them, like fitting a cog into a machine which previously was spinning endlessly. This completes all that is needed for the computation to run, and the machine runs. Okay, the output of this partial computation is itself a variable with an unknown value. Okay, this output can be placed as input to new function. So one function relies on another. Okay, so like chaining the function. Okay, or in shell maybe it is like, what is it? Piping. Maybe that's the word. An advantage of this idea over mathematical model is that we recognize that function contains computation, contains some kind of process. We see that when the computation runs, some physical process is going on in the machine. And the computation runs, some physical process is going on in the machine. Okay. This means we recognize, my stomach's growling again. Okay, this means we recognize the fact that certain things take time to elapse, or that a function might change the program state, or do anything else we are not sure about. Okay. might change the program state. All these ideas are explored in the study of function. Lambda calculus. This is a field that combines logic, math, and computer science. The name comes from the Greek letter lambda, which is used in the representation of binding variable. I'm curious about lambda calculus. Let's find out. Computation based on findings of deduction. Okay, well, let's take a look. It's up to find by a formal syntax. Okay. Finite set of terms. A lambda term correspond to the following. Abstraction is a lambda term, okay. Where T is a lambda term. Okay, well, let's continue. This again. Using lambda calculus gives a way of defining, composing, and building function using a simple mathematical notation. I am not sure if mathematical notation is simple. Well, it might be simple, but simple does not mean easy to understand. Right? Okay, anyway, we are going to use all of the previous ideas to add user-defined function to our language. Okay, after we add a variable, or maybe a symbol, I guess, we are now trying to add a function. Lisp is already well suited to this sort of playing around and using this concept. It won't take much for us to implement function. The first step will be to write a built-in function that can create a user-defined function. It is one idea as to how it can be specified. The first argument could be a list of symbols, just like the function. A list of symbols, okay. what is it called? The symbol in here means the quote expression, something like this. In this book, we use the curly bracket as the quote expression declaration. Is that the word? Oh. Okay. The name comes from the Greek, right? No, not that one. This one. The symbol we call the formal argument, so known as the unbound variable. Okay. They act as the input to our partial computation. The second argument could be another list. When running the function, this is going to be evaluated with our built-in eval function. Wait a minute. I'm kind of curious. 69. I think I've already come something like this. Alright. As the input to our partial computation, the second argument could be not the list. When running the function, this is going to be evaluated or built-in eval function. Oh, okay. We'll go just, what is it, slash, I guess, for the division to dalam the calculus. So this is not division. Okay. To create a function which take the inputs and add them together, we will then write something like this. To create a function which take two input and add them together, you would then write something like this. Okay. We can call the function by putting it as the first argument in a normal expression. We can call the function by putting it as the first argument in a normal symbolic expression. Rather than using this symbol, maybe we want to change this to something else. Maybe if we want to name this function, we can pass it to our existing built-in def like any other value and store it in the environment and together. Okay, then we call it by, oh wait a minute, this is not slash, this is backslash. Okay, yeah, I got confused, I guess. Built-in div, right, my bad. Okay, if we want to name this function, we can pass it to our existing within def like any other value and store it in the environment. Okay, so we start this function notation, I guess. Wait. Oh. Wait a minute. Oh. There is mosquito. Will you make a video series on C3 language? I'm not sure. I mean, I haven't tried C3 programming language yet, so maybe. I mean, I'm trying to learn C first for now. So yeah, I'm still not sure. We will see. I mean, there is also, what is it called? The T programming language, right? Right. So I'm not really sure. Like, what is C3 is about? And also Tilang. Yeah, I'm not sure. The C3 comparison with other language. Okay. Then we call it by referencing to it by name. Okay. Now the interesting part is that what happens if we provide a character instead of a number, like this. I mean, in this example, right? What happens if we use something like this? Will it, what is it called? Will this throw an error? Or what? Yeah, let's find out, I guess. To store a function as an L file, we need to think exactly what it consists of. Using the previous definition, a function should consist of 3 parts. First is the list of formal argument, which we must bind before we can evaluate the function. It consists of what it consists of. Okay, a function should consist of 3 parts. First is the list of formal arguments. Arguments which we must bind before we can evaluate the function. Okay, the second part is a code expression that represents. The second part is code expression that represent the body of the function. Finally, we require a location to store the values assigned to the formal arguments. Again, we already have a structure for storing variables or symbols, I guess, in general, an environment. We will store our built-in function and user-defined function under the same type alpha fun. This means we need a way internally to differentiate between them. To do this, we can check if the built-in function pointer is null or not. If it is not null, we know the alpha is some built-in function. Otherwise, we know it is a user function. Okay, in type and v, okay, formal body, okay, checking this null or not. Let me check. This one. Okay. Assign in, okay. No or not. From fun to built-in. Alright. But then if we change this to built-in, fun name. So I also change this to built-in name. No. Okay. Yes. I can see this. Okay. Yes, yes. Oh, my stomach keep growling. Okay. Phang nem, phang nem. No. Let me try. Okay. Has no member. Name built in. Struct F built in. Okay. Okay, let's try this out. And 42, okay. X, Y. Let's. I don't think we can. Okay. Correct type. X69, X, K. Wait. Alright. Go and sleep. I just woke up, I mean, in case you didn't realize, we might not have the same time zone, This is an international live stream. A lot of people might not be in the same time zone as you were, so yeah, okay. We're doing some refactoring, right? Oh, wait. Let me try this. Okay. Alright. Okay. Style. Rename file to put in. What is it called? File name to in start file maybe. I think we're, yeah, we are not only changing that in the struct eval. Use funky keyword to planning to use funky keyword to store the user defined function. So let's change the function. In name. Okay. Oh, my stomach's keep growling. I might need to get some breakfast after this. Okay. LONV, huh? Okay. Now we are storing env in the alpha to interesting. We have renamed the built-in from fun to built-in. We should make sure to change this in all the places it is used in our code. Okay, we also need to create a constructor for user to find eval function. Here we put a new environment for the function and assign the formals and body values to the space in. Lambda. I'm not disconnected. For user to find eval function, assign the formal and body values to the space in. Okay, no. Oh. Wait a minute. We built another environment. Oh, is that why now we store the environment in the alpha struct? Okay. But then we need to delete this after the usage, right? Formal body, okay. As with whenever we change our alpha type, we need to update the function for deletion, right? Deletion, copying, and printing to deal with the changes. For evaluation, we'll need to look in greater depth. For deletion, okay. Not alpha built-in. Is this in the alpha delete? Where is it? Is it in this one? Maybe. And in this case, okay, interesting. Okay, for copying, I think it is in the alpha copy this, right? Okay. If this is not null, then we just copy as is. But if it is null or other condition, I guess. Okay. Wait, do we have a case where we are copying the environment? No. I don't think so. Wait, let me check. Alpha env init. Okay. What is the type? There is no type. As far as let me copy this in the chat. Okay. there is a mosquito there. Okay. Alright. Let me make sure. LENV new. Right. There is no type. When we initialize a new environment. So what happened in here when we are copying the environment? Let me check. Copy. LENV copy. Okay. Function right. Num error. Okay. Yeah, I missed it. This is LENV copy, not alpha copy. Okay. My bad. So we create a new function, LENV copy. Okay. Okay, format. Then printing. Okay. Alright, the backslash. We need to for escaping the escape symbol, I guess. Formal. Put a row. Okay. Take the argument. Each of which are code expression. Okay. Yeah, I'm still curious about the type though. Like for example in Python, can we like do this? And A is not defined, right? Take first code. Okay. Well, let's add this first. Formal. Why we call this formal? Is it for formula? Something like that? Wait. Calculus. Oh. Okay. Let me copy this in the chat. Oh, maybe because of this lambda calculus. Formal logic. Okay. But yeah, why is it plural? I guess. Or maybe I should call it params instead of formal. And then we can call this body, I guess, for the function body or from body. Okay, let's add that. What is it again? Struct env struct file. File name maybe, or params, like the parameters of the function, and then func body, maybe something like this. Is .env, not .env, is env in here only for the function? So every time we define a function, we create a new environment. Okay. Put in. Formal seperti Should we call this lambda env? Interesting. Formal. The formal logic. We build a new environment for the function and assign the formal name. Okay. Yeah. I mean, the point is to create a lambda function, right? But now let's call it like this, I guess. And then we create a new function. Oh, my stomachs. Okay. Oh. Alpha lambda. Where should I put that? Maybe after this. This make me curious. So do we change this to verb in? No, okay. Yes. No. Yes. Okay. Okay. 32, okay. X, Y, 69. Okay. Alright. And then this one. Oh, example. Fine. Okay, and then okay, so okay. Oh. No, yes. Okay. Function name to put in name. Let's get a new commit instead. Or maybe not. This also include profile. Okay. And then maybe we should call this alpha fun. Maybe. Okay. Start alpha params body. Okay. Wait. Am I disconnected or not? Okay. I think it's still fine for now. Okay, let's continue. Struct alpha params body. Okay. First things first, alpha value, we need to allocate this, and then if value is null, just exit the program with the error message, and then type alpha file. Okay, the built-in is null, and then we create new environment. Okay, env init. Alright. Maybe I should do this instead. So we initialize the environment first, and then, or maybe not. Okay, maybe something like this. And then, but yeah, I mean, if we are trying to init environment first, and then it turns out there is a problem with the memory allocation, I can just directly exit the program before we need to assign this. Maybe something like that. Okay, and then value from params body. Okay, and then of course return value. Alright. Okay, as with method within our alpha type, we need to update the function for deletion, copying and printing. Deal with the changes. Information will need to look enter tab. Okay. Hotel, where is it? this one, okay. I mean, if the built-in is no, well, you know what? Let's do this instead. If built-in equal null, rather than using this negation, I mean, it is shorter, but at the same time, it can be confusing. Okay, so if the built-in is null, right, which means that it is not the built-in. Oh, it's not the built-in function. But then we will delete it after the evaluation. Is that what it means? That is interesting. Right. Okay, maybe we already copied that. So, interesting. Now, let's follow along first, I guess. So, my hypothesis is that this is the cleanup because we already copied this value into the environment, the current environment, something like that. We will see. We will see. Okay. I think okay. Value NV and then value from params and body. Okay, like this for copying. Where is it? Oh, okay. I need to find. I need to get some breakfast after this. Oh, my stomach keep growling. This one. Okay. Wait, not this one. Where is it? Alpha copy. This one. Right, okay. Let's do the opposite, I guess. If value built in equal null, we do something, and else we do this one. Value built in. I mean, built in and built in. I kind of forgot. Oh, not in this one. And built in. Okay. In the area we put, right? Wait a minute. Okay. Maybe let's do this instead. So if the built-in is not null, we copy directly, right? 1 second though. Well, let's try this one instead. So we check if it is null or not. If it is null, then we do all this. But yeah. Why didn't we also copy from the built-in? If it is null, right? Okay, where is it? From name. Okay. I mean, Okay, I think that's it for now. Thank you for watching and see you next time. Bye bye.